And we're back. We are in the second video here of this effort to kind of, I don't know, gussy up, detail our adjustable clip. Previous video was all about going through how to model it. This video is going to be about assembly and fasteners. We have some bodies in here. If you want, you can see them. That's the body that was the thicken, so surface body, the stitch, in other words. And the resultant. I'm going to give this name, this body 4, slow click. I'm going to call it an adjustable clip. Shocker. Once we give it a name and right click on it, make component from bodies or create component, it will pick that name up with it. Notice one thing. Currently, Fusion auto locks the first sort of subcomponent in assembly to the origin. So it's got a little anchor. From here on, we should be seeing that that's not happening. So we're going to place some fasteners here. We get a new color. It's kind of a nice fuchsia. It's fine, whatever color you have. If you shift N, you can see what just the steel, standard steel appearance. But for us, color's nice. Notice what it does down in the history. It gives us a new feature. That's quite big. Body to component, obviously. From here, I'm going to do a couple of things. One, we're going to place some fasteners. Two, we're going to run a mesh, and that'll be the end of our video. Let's do the fasteners first. We know the answer to this. If we want, we can have a look at the sketch. These holes are driven by this slot in the previous video, 0.625, better known as 5/8. Again, if we want to look at our driving sketch, 5/8, 2 holes. So that's all fine. So, sorry, I'm just going to turn myself to do not disturb. I can hear the phone going. So the goal here is to put some fasteners in here. How can we do that? There's two main approaches to this. One is to use McMaster-Carr. They basically provide a bunch of geometry that matches stuff they can sell to us. Nice. The advantage of using McMaster-Carr is that when we place something, we can also get a parts list and actually just get a shopping cart out of it and off we go. It'll be delivered. Nice. The disadvantage is they are kind of independent and they're nicely modeled, but they're modeled for appearance mostly, which is great if you're doing renderings and all the rest. But if you want to just run simulations and all the rest, it adds a bunch of geometry we maybe don't need. The other option for us is to add a fastener. Now, this is part of Fusion. Insert fasteners is a complicated thing. It's newish, but it's surprisingly competent. It's also standards based. So keep that in mind. We're going to do both here, so you get a pass at both. Let's put McMaster-Carr into the first hole, and we'll put the fastener from internal fastener into the second hole. Easy. First step, let's try McMaster. Again, sorry, if you can't find it, it's under Insert, McMaster-Carr. You get this little, essentially just a web page. You can kind of move it around in the background, but you can't really, for example, you can't do any measuring. So you have to know what you're after, 5/8, and this is 5/8 thick. We're going to put in a washer and a socket head. That's the plan anyway. Let's see how that goes. The washer is the key. The washer goes in first. But because of the way McMaster-Carr works, it just inserts a component. We don't necessarily need to place it in order. The inbuilt fastener stack, in a way, does have to go in order. In a way, it's easier anyway. Let's put a washer in first, or let's put in the fastener first. Let's do the fastener. I want an inch apart. You can make this a little bigger. I want a socket head. Now, there's a lot of them. Let's start by trying to filter this a bit. 5/8 is the size we're after. Somewhere in there. No, 5/8 11. 5/8 18. No, that's a coarse thread. That's the thread essentially. So an inch, it's threads per inch. Or, yeah, let's say threads per inch, and 5/8 18. Let's go for 18. This is quite a rough part, but we don't know what it's attaching to, so it might be just purposefully flexible for size. Let's go for 5/8 18. This will define everything more or less everything we do from here. Length, the plate is 5/8 thick, 2 times 5/8, well, what's that? 5 divided by 4, all right, 1.25. So that's better known as 1 1/4. So let's make it twice the thickness of the plate. Notice the length is under the head. Got alloy steel. Stainless, that's about it already. It's good. We see the right things here. It's black oxide alloy steel. Keep that in mind. And it's 5 for $10 US. Let's have a look. We can see the product detail if you want. That's what it looks like. And I don't want CAD 3D SolidWorks. I want 3D Step. Let's go for threads to make a point. There's a lot of information here, including its strength, its hardness, and specs. It's from the US. And then a little bit of discussion about it. They're mildly corrosion resistant. So this would be the finer threads are stronger. They're also become a little bit vibration resistant. It meets a whole bunch of standards. So if we wanted, we could, for example, take a screenshot of this. And we could keep an eye on that if we can kind of maybe use it somewhere. So there's our screenshot. So nonetheless, let's download that. This is we don't have to use the screw to drive all our decisions from here on, but it does help. So as soon as we download this, basically just plugs it into the file. There it is. Notice there's no lock here, so this is loose. And we'll just leave it where it is right now. It's nice pink. What's the diameter of this? Let's try a check here. The diameter is just under an inch. So we need a washer that's at least an inch. Perfect. Let's do McMaster again. So this can be a little tedious because you have to go in and out a lot. Washer. And you do have to keep track of sizes and all the rest. Inch. Screw size is probably what we're after. So the interior hole is driven by just 5/8 this time. Washers. There's a whole bunch here. Let's just go for washers. General purpose. There's a lot of other things. We had, what did we have? An ASTM. Come back here. We had an ASTM standard. Let's see if we can see that here. So this is ASME. General purpose, surely that's not so bad. Let's go for that. Stainless, are you crazy? No. Steel. And black oxide, that's what we want. And there's one right there. Outside diameter, looks like 1 3/8. 10 for $7. The rest is, no, it's probably what we want. Let's go for this guy. Have a look. Product detail. It's got the same coating which you would like from the fastener. So it's black oxide or parkerized, however you want to see it. It's also American. Standards. Where are we here? Well, isn't much. They're saying this is our go-to, so why not? It looks about the right size. Let's just download it and see how it goes. Looks okay. Now it's obviously not in the right spot. How do we stick it into place? So normally we're going to be using a joint. The shortcut for that is J. If you want to see it under assembly, joint, J. Because these are not as built. We'll come to that later. So there's an order here, and this is very particular. You pick the uncontrolled, unconstrained parts first. So our adjustable clip is constrained to the universe. It's modeled thus. So now we want to pick our washer first. Now, it doesn't have to be the inside circumference of that hole, but this surface, we can pick anything. It's easy to grab the outside, and therefore easy to grab the outside of this hole in the constrained part, the clip. If we pick it right, it should just swing on by. Now, type of motion do we want? Rigid? Let's get a preview. Oh, nice. How about revolute? Can't see anything happening, but it is turning. How about something else? Pin slot? Like, there's all sorts of stuff, but is this washer going to move? No, rigid. Okay. Do it again. Right click, repeat joint. I want this socket head right up against this washer now. This is unconstrained. And I can attach it to either the inside or the outside. The outside's easier to get. Ghost everything out to show us what we're doing. And again, this could be revolute and all the rest, but when you're done, when you pull away the Allen key, it is rigid. So let's just say okay to that. Nice. There we go. Placed fastener. With standards, like so there's a standard fit and all the rest. So not bad. Let's just leave it at that. We can get into lots and lots of details about fasteners. Let's just assume it's okay. For now, because what we want to do is get to the other side. We want to use the other approach inside of Fusion, which is to place by the fastener feature. Now, notice what we've got here. We've got three components now, all within our adjustable clip assembly. It suddenly turned into an assembly. So next, search fastener, or sorry, shortcut fastener, insert fastener. You get quite a large window. Depends what you did before. So basically, the first thing you check for is standards. I'm after imperial or metric. You can also clear it and get both. We're in an imperial part here. ASME is turned on. You can also ask for ANSI. But what was our thing before? Let's have a look. ASTM and ISO. That was for the fastener. So we don't have ASTM, but we've got ASME. Let's go with that for now. Just get it up. Fasteners, there's other things to place. But what we're really after here is the same order. So let's do washers. You only have to click once, not a double, once. Plain. Now, based on our filters, we've got Imperial and ASME. We only have one choice. Nice. That always makes us happy. And we can see the standard we're going to conform to, B18 22.1 1998. Click it once. You think, okay, that's all fine. You can see properties. Well, nice. But where? What you'll notice here, when you hover around, you get this little tiny washer. What it's saying is, where do you want it? You can click it. Hover. I've not clicked yet. You can also pick an edge, which will do two things at once. It'll snap it to that size and to that edge. Click it once. Can keep placing. Oh, nice. Whoa, look what it does. It looks for all sorts of curves and starts sticking them in. That's not quite what we want. So I don't want lots here. It's hidden. It's adding another one underneath here. So let's reselect. Notice we've got some options already. Select once. Now I've clicked once. You can see this green check to say finish here, but Now if I do it again, it doesn't populate all of them. Now we've got some choices here, and we can see some outside diameters. We were, I think, 1 3/8 for the other washer. Maybe that's a type A. It's close, close. Right, 1.3. But narrow type B, smaller. Narrow regular B, ooh, that's quite big. Wide A, it's thick. Wide B, a monster. So it looks like we're narrow to match what we got from McMaster. And it looks like type B. The diameter is 1 1/4, type A. That's closer to what we've got. So let's go with type A. 0.095 thick. Can't really change that. That's controlled by the standard. Once we're happy with that, so let's go for a narrow type A. I'm gonna take a screenshot of this so we don't forget. We can go ahead and create and continue, which is kind of great. So we're keeping this open, and we're just going to go with create and continue. Makes the washer for us. Creates a new part for us as well. Inside of fasteners. We'll look at this later. So just working along. So I want to go back and now do the fastener. So go back. Go back. All right, you can always go back in here as well. Bolts and screws. Socket heads, they look a little unsockety, but that's it right there. So it's not countersink for any of these. It's socket head. Don't want shoulder. Now we're still in ASME Imperial. This is good, right? We want the same standard for the washer and the fastener. It's a hex socket cap screw. ASME B18-3 2000. Now this is similar to the same class of standard, so let's go with that. It's not a spline, it's a hex. Get a little view of what we're looking at. You can open up the properties. There's a lot more here because there's a lot more geometry. Now, the problem we have now is that our fastener is going to want to sit on top of that washer. How do we size it? Notice our little tiny fastener, that's not the right size. So if we hover over the core of the hole, it thinks, oh, 5/8. But where is it? Now our next hover is on the surface of the washer. We have to click once for that. So notice it's in the right spot. What can we change here? Ignore the preview for the next placement. And we can start pulling. And it gives us standard lengths. Notice it's updating to the right there. Right, so you can either line it up by eye, because we want that 5/8 times 2 is better known as 1 1/4, or you can kind of drag and have a look. We're getting a little thing over here. You can see it's also updating our length in the designation. This is kind of great. We can also do these little drop downs here. Course. Notice it changing shape. We did a fine on the previous one, so we're not allowed 11. So this is our designation here. We're at a fine. You see an 18. Nice. 1 1/4 long. Auto is caused by the size. Once we're happy, you can either say create and continue if you want to do more stuff, like place more. You can place a whole bunch of fasteners here, different sizes and all the rest. But for us, we can say OK. Or create and continue. I find this a little more pleasant. I make sure it's right, and then I say OK. Oh, no, I don't. Now, screwed up. Right, so this guy, when I said OK, I made one wherever my cursor was hanging out. So we can undo that if we want. So let's do that again. So search, fastener. It's not a bad thing to do this twice. Get a little bit of a feel for this. So bolts and screws. We've done this once now. We can do it again. Socket head. Cap screw. Pick the surface. Right, so it kind of remembers where we just picked. Again, this is our interface, our little micro menu, marking menu. Make sure it's fine, 1 1/4 long, and we can say OK. There it is. So it's good to try this multiple times. These are all locked. You can notice we get a locked assembly. So inside of fasteners, you can see them here now. They're placed. They're not really placed as components, but they're placed as a sort of separate component fastener thing. If you edit these, you of course get the same sort of stuff going on. So this is an edit in place. Well, let's not get into this later. So notice the history gets a little serious here. One thing you can do, these are our joints for the place McMaster. These are our fasteners. If you wish, you can create a group here and call it place fasteners or something. But for us, it's fine. Leave it as is. Now, done some good work here. That's one thing we would like to know. So for example, say volume. Right click on top. And you want not property, not physical material, but properties. Manage, there's a whole bunch of stuff going on in there. But let's go for volume. 14.2271. That's what I want. This is painful because there's threads in here, little detailing. There's detailing in this McMaster-Carr part. But to make sure that you've done the same thing I have, this is the number we're after. I'll take a shot of that as well. I'll take a shot of that as well. I'll take a shot of that as well. Pressing the wrong buttons. So I'll take a screenshot of that, show all the parts. Everybody's happy. Next. And last. Go over to sim. Run a static stress, it's fine. We're only going to do a mesh here. Look at all that stuff. Oh no. What I want to do is simplify this big time. I want to mesh any of this stuff. Insane. So go into simplify. One thing we can do is right click on one body that we're interested in this case, the adjustable clip itself. Remove all except selected. Nice. Let's see what's in here. There, just that body is there. Anything else? Seems to be it. It's perfect. So simplify, remove everything. Now this is only for the simulation. If we go back to design, it's all still there. It's just simulation. So inside the simulation model itself. Run mesh by just turning it on. It's not bad. This is a simple part, right? It's crazy rough, but this is a problem. We'd like more density here. So what I'd like you to do is just follow along with what I do here to make a point. Again, we're using the mesh control. Go to, I would say, let's go to like about 5%. Should be right in the middle, of course. 5% of the model, which will give us a denser mesh. And then I'm going to go for I want to catch this fillet quite nicely. So I'm going to go to about, say, 15. Leave everything else at the default ratios. So you have 15 degrees there, 5 degrees up there. Say OK. Run the mesh again. It's quite dense, but we have a simple part. This would run not too bad. These fillets are not ultra stressed. We know flow lines. Flow lines are going to be mostly concerned by moving from these two guys over to this slot. So it's going to flow through the part. It's going to be really concerned with this fillet in the middle here. Not so much at the back. It's going to probably pull away as it flows through that corner, but it will be interesting to see if we were to run a simulation, which we're not. What is the density? Well, like what's the sort of KT running inside of here? The question that we were probably going to be asking here is what size fillet do we want in here? If this part was made by bending a piece, what break radius is it going to be using? Or if it's cast, how are we going to be modeling or making the casting blanks or molds for this guy? That's it for now though. We take a screenshot of something that looks good, try and show me this, and maybe at the same time show me the settings that you've got. Oh, can't move that. Move it into the right spot first. So give me a mesh preview with everything showing and the mesh correctly generated. So show me this as well. So you'll be looking at a bunch of pages on your PDF. We'll define it more particularly in up on D12. That's it for me. Thanks for watching, and over to you. How to model to the nth degree a simple little part like this adjustable clip.